Hello students, let's start a new topic today, that is refraction. It's going to be a very interesting lecture, as in this lecture you will come to know across the cause of certain phenomenon which you might have been observing since your childhood but unable to understand the cause of those phenomenon. For example, you might have seen a stick which is partly dipped inside the water in a transparent glass. It seemed to be a little bit displaced at the interface of water and the air. Also, you might have observed that the bottom surface of a glass containing water seems to be raised, right? Also, you might have seen that if you put certain object inside a liquid, then its size seems to be a little bit bigger. So why these all phenomena are happening? What are the cause of these phenomena? To understand the cause, we must have to understand the refraction topic properly. But before diving deep inside the concept of refraction, I would like to recall certain fundamentals which is required to understand the refraction topic. You must be aware that the speed of any wave is given by frequency times lambda, right? And since light is also a form of wave, that is electromagnetic wave, its speed is also given by frequency into lambda. From where did you get this expression? To derive this expression, I will tell you a very analogous example which is very interesting. Let's say there is a train which is having few compartments, and each compartment is having fixed length, let's say x meter. Now suppose this is a halt H, and through this halt 5 compartments passes every second. Now can you tell me in 5 seconds how much distance will this point A, which is on the front face of the first compartment, will travel in 1 second? Yeah, clearly you are right. In 1 second 5 compartments will pass through this halt. It means the point which will be here at 0 second, that must be traveled to here in 1 second. So what is the distance traveled in 1 second? It will be nothing but 5 times x meter. And now can you recall the definition of a speed? A speed was nothing but distance traveled by an object in 1 second, or distance traveled by an object per unit time. So a speed equal to 5x meter per second. So this distance is nothing but the speed only, because this is the distance traveled in 1 second. And hence you get the speed of this point, or you can say speed of the train as 5x meter per second. Analogous to this example, now let's come to the point speed of a wave. Suppose this is a wave which is having wavelength lambda. This is having wavelength lambda. Can you recall what is wavelength of a wave? Wavelength nothing but the distance between two successive crests or two successive trough. Or you can say this distance. This will also be equal to the lambda only. You can see this is a repetitive unit of the wave. So you can say this is one wave for our understanding. So this length will also be lambda. Now let's say this is the origin from where the wave is passing through. Through this point, let's say 10 or let's say for a small, to understand clearly, let's say 3 only. 3 waves are passing through this point O every second. Now can you tell me, if there is a point at time t equal to 0 second at the origin on the wave, that let's say it's point A only, how much distance this point A will travel in 1 second? Yeah, you are right. If this distance is lambda and per second 3 waves are passing through this point, so the point which is at origin at time equal to 0 second, this point must be traveled to the point here in 1 second. Why? Because 3 waves must passes through the origin per second. So this is the one wave, second wave, and this is the third wave. It means the point A, which is originally at origin at t equal to 0 second, it will travel from here to here in 1 second, and this distance is nothing but 3 times lambda. And this distance is traveled by the point A in how much second? 1 second. And this is nothing but the speed of the wave, 3 lambda meter per second. Is it clear? Why? Because what is speed? Distance traveled per unit time only. So, and what is 3 here? This is nothing but frequency. Hence we get the expression speed of the wave has f times lambda. Hope it's very clear to you. Now can you tell me one thing? What happens to the speed of any wave when it passes from one medium to another medium? Its speed changes, right? But can you tell me why the speed of the wavelength of the wave changes while it passes from one medium to another medium? If the speed is changing, then either its wavelength should change, or its frequency should change, or both should change. But what will change, I don't know. But so let's try to understand what is going to change. I will explain you with again I will explain it with a analogous example. Let's say this is your interface of medium 1 and medium 2. What happens when a light ray falls on this interface? Some part of the light ray gets reflected and some part passes through the interface into the medium 2. This bouncing back of the light ray into the same medium as of the incident light medium is called as what? Reflection. And the portion which passes from one medium to another medium is called as refraction. This is called as refraction. Okay, let's forget about it. We will discuss this later. What I'm trying to say, when a light ray falls at an interface of two medium 1 and medium 2, then some part of the light gets reflected, that is bounced back from the interface, and some part passes into the medium 2. Now let's see. Let's take an analogous example. Suppose there is a person A, here it's a person B, here it's a person C, and here it's a person D, and here is a clay. What is this? Clay. Now what person A is doing? He is forming a ball, let's say of diameter D, and he just thrown the ball to person B, and every second, let's say, he throwing 3 balls, means 3 balls per second. And means this person A is forming a ball of diameter D from the clay, and per second he is forming how much ball? 3 balls, and he throws those balls to person B. And what person B did, and what person B will do? He will just divide this ball in 2 parts, because it's now we will say, so how can this ball be divided into 2 parts? It's a clay, man, so it can be divided further into 2 balls. So let's say it's diameter D1 and it's diameter D2, and what he will do, he will throw one ball back to C, means in the same side of the A, and other part to the person D. Now can you tell me how many balls will be thrown to person D every second? Clearly, right, 3 balls only. Why? Because since A is throwing 3 balls per second, then B is doing nothing. He is simply dividing those balls into 2 parts, and one part is throwing back to C, and one half or other part he transferred to the person D. It means if he is receiving 3 balls per second, then he must throw 3 balls per second to person D as well. Now can you understand it at the frequency only? 3 balls per second, that is frequency of the ball thrown, right? And now you can understand analogously wavelength at the diameter of the ball. So diameter is nothing but analogous to the wavelength, that is size of the ball, right? So what's changing here? Is frequency of the ball thrown changing? No, frequency is not changing. Is wavelength changing? That is size of the ball changing? Yes, size of the ball will change. In the similar fashion here, the wavelength of the light will change, but the number of waves passing through a point will not change, right? So now you can understand that while a light wave passes from one medium to another medium, only the wavelength of that light wave changes, but frequency does not change at all. So whenever the speed changes while passing from one medium to one medium, what is the cause? Change in wavelength. I think it must be clear to you. Now we will discuss further about the refraction in our subsequent lecture.